America is facing a housing crisis, unlike any in its history. Depending on what you read, 6.5 million homes short, with half of all households unable to afford the American dream. The value added by construction workers today is 40% less than in 1970. And by 2031, nearly half the construction workforce will retire. We're facing an unsolvable equation. We need more homes, faster and cheaper, but with fewer skilled workers to build them.
This is Bricks and Bytes, and today we're exploring what might be the most differentiated approach to housing since the assembly line. We'll be taking you inside Cuby's groundbreaking operation across 2 continents. My co-host Martin will travel to Eastern Europe to meet CEO Oleg, where he'll witness their innovative mobile microfactories in action, building homes faster and with less skilled labor than ever thought possible. And here in London, both Martin and I will be sitting down with co-founder Alex Gample to understand the business strategy that could disrupt the trillion-dollar housing industry and solve one of society's most pressing challenges. This is Cuby, not building homes, but building the factories that build the homes.
The numbers are staggering. Since 1990, housing affordability has worsened threefold. The income required to afford an average home has increased 50% in just the past 4 years. This isn't just an economic statistic. It represents millions of delayed dreams, multi-generational households unable to separate, and essential workers forced into grueling commutes from areas they can afford.
The US has reached a very untenable position. We're not building enough homes. Today we build about 1 million homes a year. We need to build 2x the amount of homes we build in order to keep up with pace and demand. And part of the reason is bureaucratic, which I can't solve because I'm not a politician. The other problem is related to skilled labor, of which there's a massive shortage. The labor force today in the US, and this problem is very similar to not only the US, but other first world economies that prioritize white collar jobs over blue collar, meaning young people like us don't want to enter the workforce that's related to physically swinging hammers and lifting bricks and stuff that's typically physically intensive as opposed to answering a phone at a desk. But today in the US, about 7 folks retire for every 1 that replaces them. Age is shifting from around 30 years old to 40 years old, and anecdotally, if you pass by a construction site today, you see a lot of gray beards and gray hair.
For over a century, entrepreneurs have tried to industrialize home construction, from Buckminster Fuller's Dymaxion House to recent Silicon Valley startups that burnt through billions. Most notably, Katerra raised $2 billion to revolutionize construction through vertical integration, only to file for bankruptcy in 2021 after failing to overcome the industry's complex challenges. More recently, we've seen Diamond Age, Vive, and Mighty Builders all fail in one way or another. These devastating stories show the true scale and challenge of tackling one of America's most pressing problems.
So why does Cuby believe they can succeed where so many others have failed? To find out, we need to understand their 3 radical bets on the future of construction that challenge everything we thought we knew about building homes.
Cuby's story begins with 2 founders whose unique backgrounds and complementary expertise created the perfect foundation for rethinking construction. While most startups rush to market with minimal validation, Alex Gample and Oleg Kandrashru have spent over 400,000 engineering hours meticulously designing their solution, achieving what others couldn't with a fraction of the capital.
Oleg and I are both immigrants. I think that helps a bit of our story, just who we are as people and how we think about building a business, just general mentality, philosophy, mostly operating philosophy. I originally was born in Russia, moved to the US when I was super young. I spent most of my career in private equity, real estate, and development, so always around the built environment and physical buildings. I think buildings are amazing. We live, we work, we play in buildings. It's the backdrop to our lives. I think it's an important thing to be working on. When I was building a development company of a couple of my mentors, I was looking for interesting ways to build more efficiently. So I was the customer in this case. And some of the cohort that we mentioned previously or will mention in this interview, I tried to be a customer of. Either not cost effective, not regulatory compliant, not enough customization, didn't believe their balance sheet warrants them to be around long enough. So for many reasons, I couldn't be a customer despite being what I would say is the 1% of the development world that's willing to take risk on something new. I just couldn't find a solution. About 4.5 years ago, I was introduced to Oleg, my partner. Oleg's a brilliant engineering mind who was building his own headquarters for his engineers in his previous company. And he started dealing with a general contractor and developer and realized how dysfunctional that space is relative to his understanding of lean manufacturing, scaling, production, etc. And he came up with a thesis that, by way of introduction, he pitched to me. And I thought, wow, this is the stupidest thing I've ever heard. The guy wants to bring a factory to a construction site. And the more time we spent together, the quicker I realized that this is exactly what needs to happen for this to be a solution for industrialized construction. And very quickly on, I quit my job and we joined forces, and for the last 4.5 years have been trying to tackle this. Now 400,000 engineering hours in.
While Alex brings deep real estate and financial expertise, Oleg brings over 2 decades of hardware engineering experience. Before co-founding Cuby, he built and run Encata, a successful hardware product design and development company that helped deep tech startups bring their innovations to life. This background gave Cuby access to more than 100 skilled engineers and millions of dollars worth of equipment, allowing them to achieve extraordinary results with minimal financial resource.
What makes Cuby highly differentiated from all the other companies that have tried to industrialize construction to date is around 3 core tenets that we have. One is around decentralized manufacturing. We don't believe in gigafactories to produce parts or volumetric boxes to ultimately build buildings or homes. So how do you launch hundreds of factories in a low capital intensive way, in a highly repeatable way, that then service a geographic region that's much smaller? That's pillar number 1. Pillar number 2, we told ourselves that familiarity is a very important benchmark here. The closer you are to what's done today, the easier it is. For that reason, we deceptively try to look like traditional home building on site, with using materials that are non-proprietary, localized, etc. Pillar number 3 is really more of an economic pillar. We told ourselves if we can't be building homes at cost parity or slightly below, then we're completely irrelevant as a business. The pitch is really around speed and quality, but that's all priced in as upside for a developer. They care about day one hard costs. And we're really trying to be the cost-effective solution. And then I'd say we have like a half pillar. The half pillar is around cost of capital. How do we scale our business? Not using venture to go launch CapEx heavy things, which ties to our business model. We're very good at replicating factories. We're very good at day one building a business that's all about how do you copy and paste factories, and we do that in a partnership capacity with the best operators in a market.
Now we travel to Eastern Europe to see firsthand how this vision is being developed. Here, Cuby has established their research and development headquarters, the innovation engine behind their mobile microfactories. Our journey begins in Cuby's R&D center, where over 120 engineers are designing not just homes, but the entire manufacturing system that builds them.
Oleg, so we are in your R&D center. Yeah. It's quite a sizable office. It's around 120 people. Yeah. What's happening here? There's lots of computers, lots of engineers. What's going on?
Well, it's a mechanical engineering center where we do all the mechanical magic. Where we just come up the machines, come up the kit of parts, and do all of the engineering calculation and so on.
And then on the other side, we've got the facility, which is a factory facility next to the R&D center.
Well, one of our principles of the design is that the manufacturing, R&D manufacturing, should be as close as possible to the engineers, and we need to have everything in-house to produce without any outsourcing, because the iteration should be as fast as possible. Because the engineers need to come up something here, and they need to have their feedback in 20 minutes or 30 minutes. Because we do a lot of iterations, and that's why the speed of R&D is a little bit different. Let's say, for example, we will come up something, and we will hire the outsourcing just to produce this part for us. It will take a week just to calculate it, a week just to produce, a week to deliver it, and in 3 weeks, the engineer will see that he made a mistake.
So you find engineers coming to the other place
100%.
and talk?
It's number one, and they are producing also to help to produce the stuff that we're doing. But additionally, to get to the R&D center, each engineer work as a worker for 2 or 3 months just to understand all the machines, and they will not create the air castles because they will understand what they're doing. And when they design something, they will do it exactly with the CNC machine, and the workers can produce. If you want, we can look on the screen, and I will show you, for example, some part of that. For example, this is a shelving system.
Took me 1 second to figure out what.
This is a shelving system with OSB and how to control the minimum level of OSB in the factory. And that's why it's Kanban system. I will show it to you in the test factory how it's look like. And that's why we need to think not only about the tools, about the machines, we also need to think about the shelving system and about how to control the minimum level of materials. Because I told you that the construction, everything related to logistics.
So this is not a tool which is particularly getting into the house, but it's like a storage area within the factory.
It's a storage system that we use in the factory.
So that shows how detailed the whole
because
factory is.
if you will not come up even the storage of the final tools and so on, the system will not be a turnkey solution. Here, it's as I told you, it's mechanical engineering center. The guys is just come up something to the 3D models, do the design, and after that, here, this is a technological center where the guys, the engineers, is doing the software for the CNC machines. That's why they come up here. They do the preparation for the CNC machine there and to control the manufacturing operation. And after that, they produce it. We'll go to the manufacturer.
Okay, so CNC machines design or the programming.
Well, let's say, for example, you have a 3D model and you need to explain to the CNC machine what to do.
Okay.
Based on that, you take a special software and the technological engineer take this 3D model and begin to write the software
for
to the CNC machines what to do.
Understand.
Based on this design that the engineers did.
Okay, so right now there's no technology between the model and the factory. There is the need for this middle.
Yeah. This is the middle staff
side.
that they need to prepare everything to start manufacturing.
Like if I compare it to traditional construction, assuming there's a design office there, and then the construction is happening there, right?
Yeah. But the construction does not exist.
This doesn't exist.
Yes, doesn't exist. Because, and that's why
we have so much problems, right? Because it's not accurate and it's not properly designed.
One of the main problems is that the architect and construction engineer is just come up something, he don't understand how it will be assembled because he didn't take it himself. And that's why the worker on the construction side don't understand what the guy is doing. And that's why sometimes all the drawings, all these ideas, it's not work. And that's why finally the construction worker try to do as he understands it.
Yes.
And that's why we have a lot of problems, yeah, for sure.
And this is the secret sauce of Cuby.
It's a secret source of manufacturing.
Yes.
The Cuby.
Yeah. Okay. All right, shall we go to the manufacturing center?
Yeah, let's go.
After seeing how Cuby's engineers design every component of their entire system, we now move to the adjoined manufacturing center, where these designs are transformed into physical prototypes. This crucial connection between design and production gives Cuby its advantage, a continuous feedback loop on the same site that traditional construction simply doesn't have.
Here we have all machines in-house, but all of them we use only to produce prototypes and the first of the kind.
So trial and error is happening here.
Trials and errors.
Yeah.
That's why we try to come up something here to see the mistakes and so on. That's why we produce everything in-house. I will show you how it's looking.
Okay, let's do it.
Okay, first of all, here there is different departments. It means that different machines. Each of them, they have their own numbers, like you see, like a 7 or a 6, and so on here. And in this task, in the software, the workers have the exact task, what they need to do in base of that department. That's why here we have almost everything, like a laser cutting machine, we have a bending machine, milling machine, powder coating, welding inside, and so on.
Here we're about to see how Cuby uses special carts to move parts between different stations, from cutting metal to welding and preparing plumbing. Workers scan QR codes with their phones to get step-by-step directions and checklists, ensuring quality without specialized skills. This approach allows Cuby to build homes with fewer skilled workers while maintaining high standards.
This is also part of our invention, how to do the innovation in a conveyor approach. This is a trolley, like a cart. These envelopes determine each department of production.
Here Let's take the laser.
Yeah, this is a documentation with a QR code where the software, there is a full information what the workers need to do in this stage. He scans the QR code.
With the phone or with the tablet?
With the phone, yeah. He scans the QR code. He sees the exact instruction what to do. He has all the drawings and so on. And he have a checklist of the quality. When he will finish his task, he pushes the button in the software that he finished the task, and the software gives the task to another department.
So then he gets like notification that
exactly. Plus, he changed this, this sign like that, and it is a signal to the other guy that he's finished his job, and he can continue doing with this job in the next. Then he can do the next step. That's why this cart is going from one department to another, and at the end we have an assembling where we assemble the final machine or the final parts of that. That's why this is a conveyor of innovation and conveyor of the prototypes.
Cuby has created a simple way for workers to get help when they need it. This system means workers are never left struggling on their own, and engineers can immediately fix any issues that arise.
We have two ways how we can ask what to do. It's called undo button. If, for example, worker have a problem, he have to push the button and there is a signal. Also,
problem in terms of he doesn't know what to do.
Yeah, he don't understand what to do. He have some problem with the quality, with a mistake, doesn't matter. And in the technological room, they have also the signal that they see that on the stage number 5, you have a problem. And technological guys come to here, explain them what to do, or they ask engineer to come and to explain. And on the final stage of the assembling, the engineers also participate in that. Because
it's real conveyor belt.
It's a conveyor of that side.
Unlike traditional factories that specialize in one aspect of construction, Cuby's approach brings everything under one roof. The R&D Center consists of 3 interconnected divisions. The Design Bureau, where workers design on inventing and creating 3D models. The Technology Center, where technologists convert these 3D models into CNC machine programs and purchasers source components and materials needed to realize the ideas. And Prototype Production, where workers directly manufacture the product. All 3 parts of the center are closely connected and have fast feedback loops which allow for rapid creation of new products. During the production stage, the designer is directly involved in manufacturing and can make adjustments if any mistakes were made during the design process. By bringing the entire design and manufacture of construction components under one roof with a constant feedback loop between them, they've eliminated the disconnect that plagues traditional construction.
So can you tell us a little bit about what's happening here actually?
I will just walk around with you and I will show to you each department what is produced and so on. Yeah, for example, this is a department that weld the helical piers. This is screw piles.
So that's the foundation.
Yeah, this is a welding robot here. It's a Cuby robot that is welded. This is welded right now here, and it's called helical piers in automatic machine.
So this is the foundation system for
the foundation. Yeah, this is a bending press
for the secondary steel.
This is the bending machine that produces the profiles. This one that we put inside the window profile just to make it more stronger, and we produce this profile.
So here. Secondary steel work for the windows.
This is a laser cutting system using different type of steel. It cuts different stuff like for the helical piers. It's produced different parts for the foundation, different parts for the different stuff and so on. For example, here it's also working by the Kanban card. This is a Kanban card, and this is QR code. In this Kanban card, the guy is exactly know what to do. He scan it, and in this CNC system, they exactly have a request. Push the button, put, for example, the steel lips here, and it begins to weld. This is also Kanban card. You can see that you take the Kanban, if for example you take this one, and after that you need this, you take this Kanban card, this is a minimum level, you put it into the bucket,
Someone collects it in the
collect
end
that
of the day.
and come back. That's why you need to design each Kanban card separately, that it's help just to do it like that.
And these are metal as well, yeah?
Yeah, it's a steel one.
Yeah.
You've seen there, this is a warehouse of the steel. This is a cleaning machine. After the cleaning machine, the pipes go here and begin to go there into the cutting system, and the cutting system begin to cut the pipe. You can see that this is the laser begin to cut the steel, and the accuracy of the cutting is 0.1 millimeter. And that's why with such high accuracy, we can produce the framing and assemble it very fast.
Yeah, cannot be more accurate, really.
And all the holes for the drills, for the screws, is already pre-cutted. This is also Kanban system. When somebody needs, for example, some parts, it begins.
Oh, that's the McDonald's shelf.
Exactly. This is something like that does not allow you to do that. You push, you take the card, in this case, like doing like that. And after that, it's easy to open it. You can see the flag is also open. And after that, you can begin to take it from here. And this is a signal for that guy to prepare the parts for him. When he will finish, he feel this stuff and he begin to do with that one.
Do you think that in the future this manual work can be kind of robotized or?
100%. And do you know that, as I explained to you, that we have the exact coordinates of each part in the building, we can give the task to the humanoids what to do. And this is a pre-level to use the humanoids, because for them it will be easy to do that, because for the humanoids it's easy to do it like that and to take it. And we would just not only use this flag and that's it, but the process will be the same. For example, here, the same stuff, they just cut it, and this is a minimum level. You also take the card, open it, begin to take it, and this one is put there. This is the task to this guy to cut necessary amount of parts there, and that's why we control with the cards all the process of that. It's thousands of them, and you need to design. It's not just a simple shelf. You can see that. This is a shelf and the process embedded into the shelf. At the end of the shift, the duty of one guy just to come over all the factory and from this bucket take it, and that's it.
That's it.
And you should have a separate guy. Yes, everything is simple. Let's go further. This is a paint shop where we just paint the part of the terrace, because the terrace is outside. That's why we need additional coverage. But internally, we have two layers of the paint. One layer with the galvanized, and we use the galvanized one layer only for the framing that is inside this isolation envelope.
Like the plates which are inside the sandwich.
Not only, but the frame also. You can even not to cover it, because they know it's protected. But everything that we use outside, in the terraces, in the garage, and so on, we cover with additional layer. And this is a paint shop where we cover it. We put the steel parts here. Inside we paint it, and after that here.
And that's called just painting. That's not
it's a painting. Yeah,
and that's the finished product.
Yeah, that's a finish. Yeah,
and that protects from corrosion. And
yes. Yeah. And because the first layer is galvanized. Yeah. And the second layer is just protected. Yeah. Well, here it's a department where the guys is producing the magnetic wallpaper, magnetic facade. They put the magnetic film on different type of finishes here. And after that, we have a
How many patterns have you got? Patterns of the wallpaper or elevation? How many of different variations?
We have we patent the principle.
Okay, no, but how many different variations can you use? Like colors, how many different colors?
You can put the magnetic film on different type of finishes. It can be stone, it can be wood, or it can be magnetic. It can be aluminum composites that we use, and we can print on it. That's why we patent the principles itself.
Got it.
To magnetic fixation of
everything.
Yeah, magnetic fixation of the interior and exterior facades of different type of that. This is a glass cutting machine.
You purchased like a raw glass?
Yeah, raw glass, painted here, cut it here. That line, this is produce, the glass paints. We just cut it there, assemble it here, and in this oven, we just weld it. And finally, we have this type of paints. You can see that.
Okay, so that's the outcome.
Yeah, it's an outcome of this department.
Yeah.
That they produce this stuff. This quality is good.
Yeah, beautiful.
This is a department that produce plastic
Framing.
That's why we cut it here, we store it here. This is also Kanban cars that control it. Here we just put the steel profile. If you've seen there, we produce it, we put it here.
Do you have any feedback from custom? Because free pane windows is a luxury, at least in the UK. You usually have one pane. Double pane is
it's good, but triple pane is luxury.
Triple pane is top luxury.
Use triple pane.
It's luxury.
Mainly we use triple pane everywhere.
Yeah, I just wanted to mention that because it's something I don't hear every time I speak to people.
Good. Here, this is a profile itself. After that, we just cut it here. This is a welding machine that we weld, the frame here. And here, we assemble the window. We put the glass here. And this is also design table just to help you do it like that. You assemble it. After that, when you need it, you put it down. And for sure, Kanban and 5S. It's the same stuff as we have in any department, just to control the level of materials, tools, and so on.
Kanban cards.
Kanban cards and 5S system. This is machine to produce the panels. We put the form isolation here, and the two steel roll forms two steels from the coils is going there and begin to produce, the sandwich panel, and it's cut for that exact length that we need.
And that's also in the CNC pre-designed.
And each machine there understand our system, and when we download the house, each machine know what to do based on the stages.
And is it connected with the R&D brain, or is it connected with the guys in the factory?
We have the same at the same time. We have a connection with a central R&D, and we have a connection with the server in the factory.
Okay.
By manufacturing everything in-house, Cuby achieves two critical advantages: extraordinary precision down to 0.1 millimeters, and the ability to rapidly improve designs through immediate feedback between engineers and production. This eliminates the weeks-long delays typical in construction when problems are discovered on site. Now we'll see how these carefully manufactured components come together in a finished home.
Wow, nice, very nice. Yeah, I love it. I'm not just saying it because we're recording, but
This is a building for the middle class and lower, but with a good quality that they can afford.
What sort of costs are you looking at, are you thinking? Obviously, it depends on the region, I guess.
Yeah, it depends on the region because, we are recalculating based on the price of the materials locally plus the price of the labor.
Yeah,
and
even
let's
this
say, for example,
unqualified.
Well, for the factory, I can tell you the self-cost in different region. In the US, we have roughly $100 a foot.
$100 per foot.
Yeah, it's a erected building. We also supply the kitchen. It's also modular kitchens that we design ourselves, and we supply and produce it in the factory. And the construction worker assemble it. And we just also with the CNC machine do this, this part of the table, this countertop on this stuff. Here you can see
nice vaulted ceilings.
Yeah, that pitch ceiling. It's in the living area, it's create a big volume, and it's much better just to feel. Well, the windows, as you can see, it's also produced by us.
Yeah.
It's European style of the window. It's open like that, and it's open like that.
Yeah.
So do you know that you're laughing?
In the US, they don't have it.
It's not typical. Yeah, they don't have it. But when we supply the such kind of windows in the United States, in the beginning they think, well, it's not typical. Yeah. But after that, they understand.
They love it.
Yes, they love it because there's a lot of sealant here, a lot of isolation, and that's why it looks better.
And is it triple or double glazed?
It's triple.
Triple glazed. Yeah.
We use triple glass. Yeah. See, this is also the module that we supply from the factory, and you need just to connect it. And that's why we take off a lot of labor, like a skilled labor for the plumbing.
Really neatly done. I'm impressed.
This is a bathroom, and we use different type of tiles. It's not the ceramic tiles. Yeah. It's
just sort of a panel. PVC.
It's a PVC panel, and everything we install with the
very economic design.
Yeah, but we like not something bombastic or something like that.
Don't overcomplicate it.
Yeah.
How many bedrooms is it? Is it
Three bedrooms.
3 bedrooms.
Yeah.
Yeah, the
This is
size is great.
This is master bedroom. This is the closet here. Big one. This is a master bathroom. Here also.
Yeah, I actually love the space. It's so spacious. Do you remember like how much time did it take to assemble it all?
Well, this is a typical house, and when we calculate the production capacity of the factory, we calculate that the factory need to produce such type of the house a day.
One
Produce.
house a day.
One house a day.
In terms of
but-
paxes and...
Yeah, exactly, the parts. But assembling time, it's 35 working days in one shift. If it will be in 2 shifts, it will be less, but it will be 35 working days. This prototype we built 6 months.
6 months.
Yeah. Because we need to change a lot.
Yeah.
When we do the prototype, you just try to amend the technology, you need to change something and so on. That's why it takes more. For
Yeah,
sure.
it will be definitely more to do it in a traditional way.
I think that the typical timeline for the traditional construction, it's 8 till 12 months. This building was built by the people who's never built before.
Yeah, that's what is beautiful about it.
Yeah. So all of that team is here. They never do anything with the construction, and with our instruction, with everything. Also, when we build the houses, we test our instruction and the process. If the unskilled labor can do something.
Did you come here yourself to put something together?
Sure.
Yeah.
I've built myself, a couple of buildings.
Good.
And for sure, I need to understand what I'm doing.
This prototype demonstrates Cuby's vision in physical form. Quality homes built by workers with no prior building experience in just 35 working days for around $100 per square foot in the US market. But developing innovative technology is only half the challenge. For Cuby to truly transform housing markets worldwide, they need a business model that can scale across different regions and overcome the capital-intensive barriers that have caused other construction startups to fail. We asked founder Alex Gampel to explain.
I'd say our business model is intended to shift over time. Think of the x-axis and the y-axis being cost of capital and number of factories. As our cost of capital goes down, number of factories goes up, the business model shifts. In the sense that venture today, which we're dependent on because we do a lot of R&D still, because we take venture, it's an expensive cost of capital, which means we don't want to use venture dollars to pay for factories. Our business model today is to partner with whether it be home builders, ultra high net worth families that understand industrials, manufacturing, what we do. Could be home builders, developers, like I said, general contractors potentially. But essentially we offer someone a turnkey ability to become a home builder on the GC side. That's what our factory is. It's a standalone entity. That entity is then a full plug and play solution to build homes. So our business model today is standalone entities that we in partnership launch, and then we stay on to operate them while our partners offer balance sheet support and also offtake. I'd say we're probably 10x cost reduction given what we're able to do in our factories. And I think some of the companies you've covered to date, they might say they do what we do, but they're doing framing, for example. So a small subset of what we're doing, whereas our factory is truly a factory that's not a factory, fully capable of doing all end pieces of a home. So that relative compared to what a gigafactory would be about a 10x cost reduction. Our payback for context is about 4 years, which is incredibly good in manufacturing.
Cuby plans to deploy 275 mobile microfactories over the next decade, which would produce about 55,000 homes annually. While impressive, this would still represent a fraction of what's needed to solve America's housing shortage, which currently stands at 6.5 million homes. The potential market is so vast that Cuby could grow for decades without approaching saturation, and the model allows them to expand at a pace that traditional manufacturing companies could never achieve.
Our first commercial deployment, so call it real world application, is going to happen in Nevada with some excellent partners, and that's aiming for around Q1, Q2 2026.
The economics of each factory are compelling for both Cuby and its partners. Each mobile microfactory generates around $50 to $70 million in revenue annually at full capacity. The payback period for investors is about 4 years, with Cuby earning ongoing fees and equity upside. This creates a sustainable model where partners are incentivized to maximize factory output while Cuby provides technical expertise and operational support. But how easy is it to scale the mobile microfactories globally?
The kit of parts themselves sit on somewhat of a rail. So the rail being International Building Code, which is kind of an overlap of building code all around the world. But we've designed it in a way where it's flexible enough to make degrees of variation changes based on regulation as it shifts in different markets. So before we enter a market, we have different standard operating procedures for launching a factory. Part of that is adapting to local code, different supply chain, making sure it's not proprietary and mostly localized. But really the factory scales based on partnering and making sure we partner with great partners who, like I said, provide balance sheet help and offtake, and really just replicating these factories. It doesn't take much. Take a piece of land and the factory arrives plug and play.
The copy-paste model extends beyond just the physical factories. Cuby has built standardized processes for site selection, partner onboarding, regulatory approvals, and workforce training. This systems-based approach allows them to scale in a way that traditional construction or manufacturing companies cannot. Each new deployment benefits from the lessons of previous installations, creating a continuously improving global network.
Where we want to get to, and we think we're incredibly unsuccessful if we do 1, 2, or 3 of these. That's not what this business was intended to do. In our heads, the goal is around 275 mobile microfactories, servicing 200-mile radiuses each. I would say 60-70% of those will and should be concentrated in the US. What's interesting though about the US, even in critical scale, imagine we launch 100 mobile microfactories in the US alone. That means we'll be building about 20,000 homes a year in the US, which is still such a small drop in the bucket relative to the 1 million homes we build a year today in the US. But there's 2x worth the demand, so we're an even smaller drop in the bucket. So even at our most critical scale, we're still a tiny player, which is what's exciting about this space and the amount of demand it is, and it just shows how big the industry is as a whole.
Cuby's current priority is the deployment of their mobile microfactories, but their planning extends beyond immediate housing needs. The company has developed a 4-phase approach that aims to improve efficiency in construction over time.
We have a grandiose approach as to how we want to grow, but it has to be a very disciplined approach, and it's going to take a very long time. So our first phase is to get as much of the infrastructure out into the world as possible, infrastructure being the mobile microfactories. To the extent we can get as many of those out into the market, we can capture a customer base, we can get very good at reducing cost and building homes. And then phase 2, we want to ship to eventually supplying materials to the factories themselves, which is a massive business, easy to do 30% margin there alone. Phase 3, eventually, when you have the scale to and have the distribution, we will have more margin than any other home builder. Meaning today we don't compete with home builders, but in the future we may, and we might launch our own home builder that then directly has a separate tangential cost of capital that acquires land, subdivides land, and takes offtake from each one of our factories all over the place as our own customer to build homes, because we can then reinvest more in marketing, just be a better home builder altogether because our margin is higher. Phase 4 is eventually go to other asset classes. So we really want to be the infrastructure behind building buildings.
As technology advances, Cuby's standardized system is perfectly positioned to incorporate robotics, artificial intelligence, and other emerging technologies. Their modular, software-driven approach creates a platform that can evolve with technology, potentially leading to even greater efficiencies and capabilities in the future. What begins as a solution for today's housing crisis could become the foundation for how humanity builds its structures for generations to come. Historically, the construction industry has not responded well to automation. We asked Alex for his view on how Cuby plans to tackle this.
So I think we have a unique take on automation. Automation is amazing. It only makes sense when you know the positive ROI and the right direction to go into. The way we look at the space is, if you pick Tesla, for example. Tesla had, I think, 60 years to work off of Toyota's production system, and then like almost 100 years to work off Ford. So meaning there was a lot of folks and predecessors that have helped create a lean manufacturing process that took advantage of unskilled labor, squeezed that unskilled labor to ultimate efficiency, and then allowed folks like Tesla and now all the auto manufacturers to go and automate, roboticize a lot of their processes. Construction is none of that. I think, Martin, you know the space more than anyone, right? It just, you're not at a point where you even know what to roboticize or what to automate. So what we're trying to do first is take away the skilled labor equation. Then you physically keep pushing the efficiency until that skilled labor moves to unskilled, to then least amount of labor hours. Then once you've you can't squeeze off any more efficiency, that's when you know what to roboticize. So we don't buy this whole thing, automated day one, no humans involved. It's not happening. And as soon as someone says that, that means they're doing one subset of the thousands of steps it takes to build a home. What we're doing is reduction in skilled labor. Our software, our hardware allows us to do that. Once eventually we get this right, and we're probably one of the only groups that has mapped the 10,000 steps, micro steps it takes to build a home, which means we have proprietary data that eventually, this gets really exciting when humanoids become part of the equation, because a humanoid can't just go and do construction, right? Like it needs to train off something, it needs models and process mapping. We have that. So in theory, we're best positioned for ultimately if someone gets humanoids right, because our factory is the same blueprint every time, the same core process mapping every time in terms of functionality. So one day we'll get to robotics, one day we'll get to humanoids, but today it's about reduction in skilled labor by definition of Toyota's production system.
Cuby's ultimate goal transcends business success. They're working toward a world where quality housing is accessible to all. By 2035, their network of mobile microfactories could be producing over 50,000 homes annually while creating hundreds of thousands of jobs for people without traditional construction skills. This vision represents not just a company scaling its operations, but potentially a fundamental shift in how one of humanity's most basic needs is met across the globe.
Well, in a more kind of dry way, what we do at the end of the day is we design, develop, deploy mobile microfactories that manufacture and assemble homes to start. But really what we care about personally is Oleg and I want to be the two people in the world that have built more homes than anyone else. It's as simple as that, and I think the world could use it. Like I said, homes are an important aspect of, Maslow's hierarchy of needs at the end of the day. It's shelter, right? It's where you feel you live, work, play. It's a backdrop to everyone's life. Like I said before, we care a lot about delivering on that, and the world doesn't need, the Ferrari of homes, they need the Toyota. We need to make homes accessible. I think you look across the world, that's where there's a bit of a struggle today. Homes are too expensive, we're not building enough, and it's a simple economics equation. You build more, cost comes down, and everyone gets access. So we're building the platform to do that.
Cuby represents a fundamental rethinking of how we build homes, not by changing what we build, but by transforming how we build it. In a world where innovation often focuses on digital experiences and virtual worlds, Cuby reminds us that solving tangible, physical challenges may be our most important work. Their approach could not only address the immediate housing crisis, but potentially reshape how we create the built environment for generations to come.
A lot of technology has been focused on making life more convenient, and we're forgetting about big real-world problems. Housing is one of those big real-world problems, touches every single person on Earth. And, I read something statistically that we need to build 2 billion homes over the next X amount of, decades or whatever. It's a lot of homes. And we're definitely not building them. The housing crisis took decades to create. It won't be solved overnight. And I think what we're working on is critical, it's important. And I hope that we solve it by building the infrastructure for building homes and hopefully making a lot of folks' lives better in the process.
If Cuby succeeds, and we need it to, it won't just build a valuable company. It will help solve one of society's most pressing challenges and restore the promise of home ownership for millions. In an era where we often measure progress through digital innovations and software advances, Cuby reminds us that transforming how we build our physical world may be the most profound innovation of all. The factories that build the homes. This multi-layered vision could be the key to unlocking a future where quality housing is truly accessible to everyone.
To learn more about Cuby and follow their journey as they deploy their first commercial mobile microfactories, visit cubytechnologies.com.
Thanks for joining us for this special look inside Cuby's revolutionary approach to solving the housing crisis. If you enjoyed this episode of Bricks and Bytes, please hit that subscribe button and turn on notifications so you don't miss our future explorations of the technologies reshaping our built environment. And let us know in the comments what other construction innovations you'd like us to feature in upcoming episodes. Until next time, I'm Owen Jury for Bricks and Bytes.